work group. Paul is a California Office of Emergency Services certified trainer and has actively trained architects and engineers across California to be able to respond to major disasters through Cal OES deployment. Paul is committed to maintaining the architectural beauty of the Central Coast of California while protecting the environmental quality, resilience, and sustainability of our community for future generations. Also on the webinar is David Knight of Monterey Energy Group and one of our silver sponsors. Polly Osborne, our board VP, will be moderating our Q&A session. To thank Paul for being here, and I'm going to let him take over.
Thanks, Libby. So like Libby said, I'm Paul Poirier. I have a little 6-person practice here in Santa Barbara, California. I was on the 2030 commitment team work group at AIA National. And I really think that this tool is super valuable for small firms operating kind of in the realm like my firm and many of my friends here in Santa Barbara who are architects of small companies. The goal of this program is to really provide a speedometer for you to look at how your practice is doing and how you are designing buildings and to track your improvement as you go in time to do projects better and better every year. And if we don't really start measuring how we're doing, we'll never know how we're doing. I know there's a lot of anxiety about, say, stepping on a scale to find out how much you weigh or checking your blood pressure or going to the doctor to get a EKG on your heart when you start to get my age. But we should do it if we want to stay healthy and if we want to improve the way we're doing things. And this addresses your professional ability to do that. So this is what I want to try to cover today, and I have to go super fast, but I'm going to try to blast through it in an hour and then take questions and dive in deeper if we need to in any areas you have questions on. So what's climate change? Why do we even care? What is the commitment? What do the signatories do if you sign up and you start doing this? What other tools are there that the AIA has provided to help you go beyond just the DDX and energy performance to track water conservation and other items? What's the common app for design excellence? And what lessons do I have from the field and what are some resources available? So climate change, architects, why should we care? Because we make a big difference in how much carbon gets generated, how we design our buildings, how they operate, function. We're starting to learn about embodied carbon in the materials we select. So in 2018, the UN Intergovernmental Panel on Climate Change reported that we need to limit global temperature change to 1.5 degrees Celsius, or some bad stuff's going to happen. And some bad stuff is starting to happen. So strange. So this is our Lake Cachuma, where we in Santa Barbara get our water. Luckily, it's fuller than this, but when the lake gets this low, we start to panic here on the Central Coast because this is our freshwater source, and it's piped through a tunnel through the mountain to us from an inland valley in the San Ynez Valley. I'm not sure where Monterey gets its water, but you've probably seen maybe not as bad of fluctuations of crazy flooding and drought. This is kind of weather we've been having in Santa Barbara lately. I think this is from 2018, and it's just not normal Santa Barbara weather. This is from the 2018 debris flow. We had kind of an event here that, resulted in 23 fatalities. This is where we had a fire run through up in the hills above Montecito, burned all the ground cover, chaparral, trees, and everything. And then everything was covered with a layer of snow globe type dust and ash. And then it rained some insane amount, and it caused a giant debris flow that wiped out a bunch of houses. So 23 fatalities, 167 injuries, 408 damaged homes. The topography of Montecito changed anywhere from plus 16 feet to minus 8 feet, depending on where the debris flow and all these boulders ended up. The houses were just ripped off their foundation, pushed down into the ocean in some cases. And it's just not normal weather for us. And lately, you guys literally had the sky the wrong color in the Bay Area. I believe this is from, 1920, when you had all the fires in Northern California, experience what we had been seeing in 2018, 2017 on the Central Coast. Australia, Bangladesh, India. It's a kind of worldwide problem that we're having and seeing the effects of global climate change in our daily life. And building operations are responsible for 30% of greenhouse gas emissions globally. So the onus is on us to see if we can make a change in how buildings respond to this climate emergency. Design strategies have the greatest impact on building energy use. That's where architects come in. And luckily, the AIA is actually doing something about it. In 2006, we published the 2030 Challenge. In 2009, AIA established the 2030 Commitment Program. And in 2019, if anyone was in Las Vegas at the annual convention, it was brought up from the floor to make climate change the top priority of the AIA, and the resolution passed almost unanimously, but not quite unanimously, to redirect the efforts of AIA National. It's really a big thing to make decarbonization of buildings and addressing climate change through building the top priority of our organization. And I know in the past, other organizations have carried the torch, but I'm proud to have AIA step up and try to do this. So our mothership is actually telling us to do it as well. So it's going to play out in our cities and the buildings as we double the current global building stock in the future. Ed Mazria generously donated these slides to the presentation, and he's just looking at how cities are going to expand and people are going to be migrating to urban areas and buildings are going to get renovated, and how we need to do that. In the US, 113 million existing buildings are here, and half of them will need a retrofit in the next 10 years. So if all of the architecture firms in the country can do these retrofits and lower the carbon emissions and operating carbon and embodied carbon of these remodels, we can start making a dent in the existing infrastructure. And if all of the new buildings also can meet a better standard for carbon emissions, we're going to make a big change. And then this is a statement that just says that when we don't address climate change, the low-income folks are the ones who bear the price. So the poll's kind of in, and it says 94% of you have heard of the 2030 Challenge, and only 33% did any research to figure out what it is. Everyone's busy. Everyone's has the challenges of COVID to keep your offices going. Hopefully I can tell you about it and we can look at how you do it. So this is about making the commitment. What does it mean? So the mission of the commitment is to transform the practice of architecture in a way that's holistic, firm-wide, project-based, and data-driven. So hopefully we're moving from 60% reduction, 80% reduction over the baseline energy use to becoming able to design 2030 projects that are carbon neutral and net zero energy. It can be done. If I can do it, you guys can do it. Clients responding positively to it. The myths takes too much time. I know everybody's busy. I know we do about somewhere between 40 and 60 jobs a year in my little company. A lot of them are like replacing a grease interceptor for a restaurant in response to a violation, or putting in some car charging stations. Don't really apply to this program, but we do buildings too, tenant improvements for commercial, some small residential projects, some ADUs, some shopping centers, some other bigger projects, and luckily some super green projects that are fun to do also. But we find that it takes about 30 minutes to do the input data into the DDX. Most of it is done. We do it kind of tax season style, do it all at once. But if I had my act more together. Our design teams that are working on different projects will be doing the input data into the DDX as we go through and do the projects. And as the Title 24 energy models come in, we're in preliminary design and design development and upgrade it when we update it, when we do CDs. Takes too many resources. The program's free. I delegate to 2 of my employees to help me do the input on the design data exchange, to record the projects and their performance. So we split the work 3 ways, and we're able to do it in between doing other stuff. Takes us about a week, but not a full solid week. If I say, hey man, do these projects, you do those projects, and I'll take care of these complicated ones, then we can get it all done in about a week's time, and it's not that much work. You know, if you're afraid to see how you're doing, all the more reason to step on the scale and check it out. If you have the goal of improving, you know, I think you need to know where you stand. And once you start measuring yourself annually, you're going to see, if you're trying, that you're going to have marked improvement. And I signed up in 2009 and recorded my 2009 data in 2010. And I've had steady improvement over the performance of my firm. And it changes the way you look at projects and think about projects when you're working on them. And it kind of lights a little fire to ask people to put solar in, or to force your envelope design to be a little tighter, and to improve the overall performance. So the benefits: you can be a climate leader. More importantly, you could be looking at the speedometer and the odometer of your office as you're moving forward. Clients and people who work for you can get on the program to see that you're a firm that's dedicated to this and improving your performance, and you can get recognized. A large number of the companies that get code awards, every firm that's received a code award since 2014 has been a 2030 signatory, and use some of these tools that are available to be able to do award-winning high-performance projects. So these are the 5 steps you need to do. Sign a commitment letter. I included a template commitment letter. If you're super lazy, just put your name and your firm name at the top and get the principal to sign it, send it in. If you feel like customizing it, feel free to do that too. But that's included in the stuff I sent out yesterday as a Word document. Create a sustainability action plan. We'll talk about that a little bit. Try to meet the 2030 targets with your work. That's an 80% reduction over a baseline energy use. We'll get into that a little bit later. Try to report all your projects in the design data exchange, and then update your sustainability action plan as you go forward. And I did our first sustainability action plan in 2010. And I don't own my building, but as opportunities arose, we got an Edison rebate to upgrade our T12 lights to T8s, maybe in 2012. And then recently, a new guy bought my building, and we are able to strong arm into upgrading our T8s to LEDs, dimmable LEDs in our office now. So we have achieved our original goals and some in that account. So if you're interested in this program, after I explain it to you, the first step is writing a letter and making a firm commitment, firm-wide commitment that you want to be on the program. So as I said, there's a template letter. You create a DDX, Design Data Exchange account, at that address, 2030ddxaia.org. You get the letter. So say you're just a project manager and you're interested in getting your firm on board, talk to the principals about it, have the principals sign the letter and turn it in. It's important that you just don't go rogue on them and do it for them, but that you get the ownership to dedicate and make a commitment to trying to do this. And for me, it's easy because I'm the czar of my own company. So I just have to convince myself to do it. And then I tell all my employees to do it, and I can allocate manpower as needed to get the little bit of work that it takes to get this thing done. The next part is making a sustainability action plan. I think I uploaded to you guys a guide to do that. Basically, it's what can we do around the office, and what about our workplace can we do to make it greener? So it's looking at walking the walk and figuring out how your work environment can be greener. So of course you make the commitment, You look at how are we going to do reporting? How are you going to do outreach and advocacy, training, operations? What other things can you do? There's some links online for you to look at that. And as you go through the program on the 2030 commitment, as you sign up, it'll guide you toward templates and other sustainability action plans you can look at. So here's what we did with my company, right? We had occupancy sensors and upgraded our T12 lighting a long time ago. That was our first SAP. Then back then we actually had monitors that weren't flat screen and weren't Energy Star and the big old huge CRTs. We upgraded a bunch of those monitors and shut everything down but the server at the end of the day. Starting to maximize the use of electronic documents and PDFs. We were burning trees like there was no tomorrow here, sending 12 sets to the Orange County building department and things. But now with COVID, it's actually accelerated digital plan check and PDF submittal of documents and PDF sharing of documents with consultants. So one good thing to come out of COVID is the virtual operation of the office operations and the reduction in paper. Firm-wide recycling and composting program in our office. We have composting bins, we have recycling bins, and we have these teeny tiny ashtray sized bins for plastic. Mostly it comes in the form of plastic wrapping on binders we might get or CDs we might get from consultants. Covered bike parking here at our office, Zoom, Uber, all that stuff helps. So that helps us keep the environment in mind as we come to the office every day. Third part is endeavor to get your projects to meet the goals of the 2030 commitment and the 2030 challenge, which was, in the early 2000s, Ed Mazria came up with this plan. Man, we got to get to net zero energy by the year 2030. How are we going to do it? Every 5 years, we're going to ratchet it up, starting with 50% today, 10% every 5 years. So 2010, we're supposed to get to 60%. At 2015, we're supposed to get to 70%. 2020, we're supposed to be at 80%. 2025, we're supposed to be at 90. And by year 2030, we're supposed to all be doing net zero energy, net zero carbon. Now, he's added. So we're in the 80 percentile. Actually, I think it was 2019, my company's average made the 70% for 1 year. And we're, I think, at 69% for last year. So we're falling short of the 80%. So I have a ways to go, but there were a number of companies that did it last year. I'll show you at the end of the presentation. So every March 31st, you are supposed to inventory all the projects you worked on that year, update their status, whether they're active or not, and then input the data that you already have from the models that you do, or your consultants do for you, in my case, into the design data exchange to become part of the database that you can refer to as you do your project. If you have an interior project, I have a ton of projects that are just TIs. The mechanical system's existing. We're just tweaking some ducts. We're not really touching the envelope. The shell architect did, or it's an existing shopping center and I'm doing a restaurant in there. So you only calculate light power density that's on your electrical engineers LPD energy forms. And you input that data and you just go on to the next one. If you're doing a new standalone building, you'll be incorporating data that's buried in the mechanical engineer's envelope and mechanical system performance calculations along with the LPD from the electrical. And then you're supposed to update your sustainability action plan every year, every 3 years, that is. Kind of keep it current. So what happens when signatories participate and who are these people? So small firms, 151 small firms active. This is old data from 2019. I sent you the 2020 data report in that pile of stuff that you got emailed so you can review the current mix of folks. And then who submitted their portfolio. So these are the people who said, I want to do it. And then these are the people who actually submitted their stuff. So of the 151, only 36 people from small firms submitted. It's so easy for us to do because we don't have that many projects. 130 big firms did it. 106 did it. So they're like probably like almost 90% of them did it, and only a small fraction of the small firms did it. But I'm going to hopefully show you that it's not too hard. Where are they from? In 2019, they had this nice map that showed the whole United States. And you can see where the people who are interested in the program are. California should have way more participants because we do all the work already. Where they are in the world, all over the place. What's the impact? It's pretty good and getting better as more and more people participate and record their information. They have data. This is how the data, they present it in a couple of different ways. And I've been working with the committee to come up with ways to modify the DDX to provide more of this data. The large firms are lobbying to have them be able to compare their New York office to their Tokyo office to their LA office. And I'm advocating for small firms to say, I don't really care to dice my internal organization because I have 6 guys. I want to see what everyone else is doing so that if I'm doing a single family residential that's modeled, and this is the mean in terms of performance based on the baseline energy use, this is the mean here at 63% or so. I want to put mine at least in the top 75%, which would be 82% performance or above, if not all the way past 100 and maybe generating energy and be way over on the right side of this line. Or if you're doing healthcare, it would be maybe a little more limited. And just looking at this, it looks like retail and office are the most limited in terms of improving the performance. But that might be that retail and office aren't using renewables to bump these numbers up. And it would be pretty easy to do that. And this green line here shows where the 80 percentile is. So we can see that the average in every different building category is still below the 80%, except for single family residential is getting the closest, followed by surprisingly modeled labs. And of course, modeled projects are going to perform higher than non-modeled projects. And almost everything in California needs to have an energy model, with the exception of a super minor residential remodel where you're just swapping out a window or swapping out a door or something like that on the exterior envelope. Saves money for your clients. When they start learning that, they're going to start coming back to you with more work. School architects, I'm not a school architect, but they're able to build their vocabulary around energy performance and dollars for operating expenses. And it makes a difference in terms of the school districts that you're able to do buildings that have lower operating costs and explain that to them. And we need to keep doing better. We're down here and we're supposed to be up here. There's always a gap. The gap's getting smaller from where we're supposed to be to where we are, but we need to try to pull architects up and collaborate with each other and share innovation so that we can get to the goals if we're going to try to get to net zero energy by the year 2030. So let's talk a little bit about the DDX. And I'll show you a couple of things that I've done, and then I'll go into a little demo on it for you. So the concept that I use in my office is to try to reduce the overall projected energy use intensity for the building and facilities. So we're trying to over insulate the envelope, use a super efficient, hopefully I can tell my clients and sell them on an all electric VRF or mini split system that doesn't use fossil fuels, high efficiency lighting, daylighting controls, dimmers, other high efficiency building system, ERV or HRV, energy recovery ventilator, in addition to some kind of mini split systems. So this is the Forest Service project we did in Solvang that was zero fossil fuels. So it's all electric with solar on the roof. This is a community arts workshop retrofit project that's reusing some old funky buildings that used to be the auto pool and a brownfield site for the city of Santa Barbara. Now arts project, but high efficiency efforts made there. And then once we push the projected energy use intensity down, we're adding on-site renewables to try to offset that electrical use. This is a project that actually, geez, it was probably almost 10 years ago, David Knight and I worked on, where he did a TI over on the left-hand side of this building before this current property owner owned it. And before we had done this whole design to fix this glass box. But anyway, we put solar all over the roof, solar around the edge to shade the glass, replace the storefront. We weren't able to get fossil fuels completely removed because it had an existing 4-pipe system. And when the mechanical system was designed in 2016, there was no way to get a commercial boiler that was all electric that could meet the demand that we had. I understand that new stuff is coming online right now that currently could do this, but nonetheless, it's way more efficient than it used to be. So let me just bail on this for a second. And let me take you to the DDX and show you what that is, because you guys are probably going, what the heck? So this is my DDX. Probably shouldn't share it with you, so don't tell anybody. But this is the DDX for my office. So it has a listing of every single project that we've done in the last few years. And if I go and I put one in accidentally with the wrong number, so we'll tinker with that. This is the wrong job number. So we're going to go in here. So it's a house project. So I would, oops, let me just go back here. I would click on create project, and create another one, just fictional. Okay. So we'll call this test office project. Okay. Project status is active. It automatically gives you this number because that's my ID number within the DDX. I don't even need to know it. Project type, say it's a whole building. Construction type, new construction. My only office in Santa Barbara. USA, got to fill all this stuff out. I'll just say it's in Santa Barbara, California, just to keep it simple. Automatically fills out the climate zone for you when you put the zip code in the city and the state in. And it asked me if I want it in metric or imperial. I'm doing imperial. Okay. So I just put in that data for the project, right? The basic stuff you get off your cover sheet. So boom, go to the next page. Estimated occupancy, let's just say that this would be 2022. Energy code used would be California Title 24, 2019. Say there's 10 people in it. I usually don't disclose this without permission from the clients. So I usually don't disclose this. Estimated building costs, site costs, total construction costs. And then we come down to here, the use type. You can go down and say what it is. There's all these different options, but it'll be a small office less than 10,000 square feet. We'll say it's 8,000 square feet. Okay. So I put that in. Automatically gives me the baseline based off of the use I selected and the area of the building. It tells me that the baseline BTUs per square foot per year is 50.53, and to reduce it by 80% is this number here, if I want to meet the 2030 commitment. All right. I'm allowed to change my baseline if I want to say, well, this office building has a server room in it, so it's going to be more, and you'll use some data to generate it. I don't even bother with that. I just go, give it to me. We can beat it, right? So that's pretty simple. So I save this window, go on to the next. Now let's say we did so now the next table says, that's your target. This is my target. This is where the average office building in, I think, of reported projects coming at 25% better than baseline. This is where California Title 24 is 59% better than baseline. So I'm hoping my project is legal in California and is up here at least, right? Anyway, not changing any of that stuff. So it gives me a baseline, and it's telling me similar projects are like at 36% better than energy baseline performance. And it shows my firm, this up here is the 80% line. So gives me an overview of the data, the target. So let's say we want to add some design data, and you get with your energy modeling person, and it's a commercial job, and you're in the concept phase, and you're trying to get it, and you're going to go, yes, we're going to predict the energy use for the project. And we're going to go, okay, we're going to use Energy Pro. I'm not going too fast, but, and I'm going to have an engineer do it for me. And he's going to do it today. And I get with my energy modeler, and I only pay him $500 to do this because it's not that much more work, because he would be doing this for me anyway to get me a permit, right? Maybe it doesn't even cost you any extra money. In another state, like say we were licensed in Alabama and they don't require energy modeling to get a permit, it might be the entire mechanical engineer's fee to do an energy model, because all they do would be something way less. But in California, we do the heavy lifting already. So it's all right there. So here's the cool part, I think, fuel sources. So we say yes. So I don't do this stuff in house. Smart people do. Like take, for example, Andrea Love or other sustainability managers from architecture offices in San Francisco, or guys on the East Bay. They have somebody, their whole job is do a Sapphira model, figure out the amount of electricity that the project is going to use. So we'll put grid electricity in. And they go, okay, how much electricity is the project going to use? And you put some number in there that comes out of the energy model, and boom, it tells you how much energy you're using per year. And then you go, how much gas are we going to use? And you're unable to tell your client right off the bat that they say, you can do everything, but the stove in the break room has to be gas, and you have to put a commercial hood in too. So they use 11 therms just for the stove. So you're going to have a big argument with them over putting in an induction cooktop, and that you're justifying $15,000 worth of gas infrastructure for one stove. And that if you took that $15,000 out and put an induction cooktop, you could make this down to zero. So then you have on-site renewables, right? So you get with your guy and he says, okay, we could have, hopefully, that's too much. 20,000 kilowatt hours solar, which I think is about 1,000 square feet of solar on the roof of the building. Then you can see that the electrical use, the gas use, you finally win the battle. You're able to get rid of that. Now you're zero net carbon. All right. So these numbers are extracted straight out of the Title 24 energy calcs that you're usually looking at. So let me try and show you. So this is one here. So this is showing what the standard design would be. This is table C3 on a 2019 Energy Pro Title 24 form that gets stuck. So the instructions are as a separate Word document to look at, but basically if it's a 2019 non-residential project, you look at this table, and this table, once you start to learn how to read it, is super cool. It's like, this is what your allotment of energy that's maximum allowed by Title 24. Granted, it's probably 59% better than baseline already. This is what my project actually uses in terms of electricity, less than the allocated electricity for it. This is the gas that's allowed maximum. And because we went all electric, partially because we like to do green, but also partially because this is in the boonies and it's for a weed farm and they don't have natural gas there. It would cost a fortune to pipe it there, or propane. It's an easy sell to get them to go, carbon, don't say, we're gonna do carbon neutral. You're gonna go, dude, we're gonna do all electric for you and offset it with solar. And they're like, yeah. So zero, so this represents a bigger savings, not using any gas and even staying under the budget here. Even if I exceeded the budget by 23, say megawatt hours here, and I did zero here, I'd still be below my overall performance pre-mandated amount of energy use. And then on top of that, so you put those two things in over here, and then boom, you get that, you can get down to zero by offsetting it with solar. And so I have a good solar vendor here that we use. It always helps me figure out what this number is and what the size is, and how much, depending on how it's oriented, how much solar generation I could plan on getting to offset this, to make it zero net energy and zero net carbon, because we're able to eliminate the gas, right? And then if, here we're like, okay, we got PV on site. If you could do any of these other things as well. We've done straw bale houses with solar thermal, that's, heating hydronic going through the floor slab and things like that. So you could click all the ones you want. Now they have that community choice energy. Let's say that you said, yes, we're doing community renewables for whatever electric we're getting, and we're not doing 100% offset. You can click that, and all of a sudden you've reduced your footprint by signing up for renewable community choice power, if that's another option, if you don't have access to sunlight because you're on the north side of the hill or something. Then you would also go down here and pull your, since it's commercial, light power density, say, yes, we did it. And you would pull this off of your energy calculations from your electrical engineer. He would have the watts per square foot of what you actually did. And he has a budget as well, but you put that in, that combines with the other one. And then this is like extra credit points if you're super hardcore and they're going to be developing this cell about embodied carbon. And actually it's something I don't know that much about, but it's blowing my mind because it's so important. Basically, it's a measurement of how much carbon it took to make the materials that you're using. So a friend of mine, he used to be the executive director of the Santa Barbara Contractors Association, retired, and she got suckered into working for Cal Portland as their sustainability manager. And so now she's trying to figure out how to do low embodied carbon concrete that meets all the structural requirements for Caltrans and structural engineers across California, Oregon, and Washington. And it's really, really an exciting field. Like, I know that we used to replace Portland cement with fly ash, and that's an easy way of reducing the embodied carbon because you're taking a waste material, but from a super polluting source and offsetting the Portland cement. But there's other crazy things they're doing now. They're putting different size aggregates in a concrete mix to reduce the amount of Portland cement that's needed. So they're just putting different size rocks in there to make it have a lower embodied carbon. And then there's some other sort of things they can put in there to offset besides slag and fly ash that are making these other kinds of concrete that I gotta learn about, because I use a lot of concrete and every building has foundations, and that is interesting. And then you can actually do a calculation through some of the software like Tally and some other software that's starting to come out about how do you show in numbers how much energy and carbon you're saving by renovating a building as opposed to tearing it down and building a new one. And I've convinced clients in the past, mostly on a monetary basis. I had a church come to me quite some time ago, 20 years ago, and they said, hey, somebody donated us this building and we're ready to tear it down and build a new church. And we have $100,000. And I said, well, first off, you don't have enough money to build a new church for $100,000 on that site. If you can get $200,000, maybe we can rip out the commercial interior and make the existing building with a $100,000 seismic retrofit into a church for you with $100,000 worth of minimal lighting and just the minimum to give you infrastructure and a sound system. And it turned out to be ideal for them. And I know they saved a lot of carbon by doing that, but I couldn't quantify it until now. So I'm trying to get and figure out with my employees how we can figure out embodied carbon and how I can go, this is how much you're going to save by saving that building. So that's a little deep dive into what you get when you dive in there. So let's just say we did all that stuff. And I'm missing a box, so it's not going to let me save. I'm missing some data. Oh, it's missing this. So we'll say no. So I'm still missing some information. Over here, we'll go back to 11 just for kicks. Now it'll let me because I put gas in. So then it tells me that my target was this, and I'm way below because I have so much dang solar on that little itty bitty building. And from the baseline to the target to the predicted EUI, mostly offset, had to be offset to get that low with renewables on site. But then that goes into my portfolio and would average out. So that's how this tool works. And then if I were to go in here, then I can see again where things are all falling on that in terms of whatnot. So I can go through and see all of my projects, and then I can do a firm report. Say I go back to ancient times, like 2016. This is taking my entire company portfolio of work from 2018. Every job we spent money on that basically was active, and averaging them all together, the predicted EUI was a little bit over 40% back then. I'm clueless on this. So embodied carbon, don't know how to do it yet, but we're gonna figure it out. But you can then see how you're doing year to year in terms of, for interior TI, which I do a ton of, this is just taking the lighting. Everyone's using LED, so it's easier to beat code. No problem. So you can go look at how you did 2015. We were lame, we're at 19%. And I think I had a zero net energy straw bale house in there, but I probably had a couple of huge Walgreens stores in there too. Another large commercial that's like skewing my average square foot performance. So then I start going, man, we're going to bootleg some massive energy savings. So I can save 5% on a giant grocery store. It's going to make more of an impact than getting that last 5% on a 2,000 square foot house. So that's what the reporting tool is all about, and that's what this is all about. But let me jump off of this so I can finish out the PowerPoint for you here. So advocacy in California. What we're doing now, the AIA California Committee on the Environment, is trying to eliminate fossil fuels from the building sector. So there's 53 jurisdictions currently that have these goals as ordinances. City of Santa Barbara, San Luis, Ojai, Carpinteria, they're all looking at adopting REACH codes that will say make all new projects all electric starting now. Not remodels or additions, but all new ground up projects. There's 53 jurisdictions that have different incentives for electrifying the building sector. That means induction cooktops for residential. Usually there's exemptions for commercial restaurants to be able to use gas and for pool heaters to be able to use gas. And there's couple little loopholes for this and that, just because it's too painful for those industries to get it dialed just yet. But nonetheless, the stuff is coming. So if you don't learn how to design an all electric home, you're going to be somewhat obsolete. Oops. So these are projects that did all electric buildings. 302 all electric buildings were recorded in the DDX last year. This is in 2019 or last year. This might have been 2019. 75 to 99% electric, 140. So they're getting close. A lot made it, some getting close. Poor performers, even less than good performers. So that's a positive sign. So we're doing some net zero carbon buildings like this Forest Service building we did in Solvang, all electric space heating, all electric kitchen, reducing the embodied carbon. This might be something David Knight even designed at 130 Robin Hill in Santa Barbara. It's a mini split system working off of a 4-pipe, but it's similar to a mini split ducted system that could be all electric. Embodied carbon, 1% of the reporting people are starting to look into it. So don't feel bad because you're not part of the 1%. But we want to grow this. I want to be part of the 2%, but where do you fall on the list? You want to be part of the 25%, part of the 2%? We just got to figure out how to start figuring this out and making a dent in this emerging field. And really, it's going to fall on California architects to do it because other people are just struggling to come to terms with an energy efficient envelope. Beyond zero. So let me just briefly, ever so briefly, because I want to be done in about 10 minutes, talk about the framework for design excellence. So this is what the AIA National Code has been doing. They define these 10 areas for design excellence. And this is for getting design awards and is for doing killer coat projects. So they have these 10 things. Integration, that's like integrated design. Bringing your mechanical, electrical, other engineers into the design process early so you can do something that's a holistic approach to meeting the goals. Equitable communities, is it accessible to all? Is it close to get to? Can people use it? Nice to the ecosystem, low water use, affordable, low energy use, which is just the focus of the DDX. Designed for well-being and health, resources, change, and discovery. Is it going to help other people learn from it to do projects? So they have this thing called the Framework for Design Excellence. There's a lot of documents to learn about it. There's a whole presentation I can give on it, but I'm not gonna. They also included in your packet of things, the super spreadsheet. So what this is to help you, you can open the super spreadsheet and it has the 10 tabs on the bottom for you to look at and try to figure out, how am I doing on discovery? How am I doing on water? And then it has cells you can fill out. If you want to do a deep dive and track your projects with this thing, you can do it to push the envelope in all these different areas. If you have an exceptional project that's super green, I think it'd be a fun exercise to make sure you got all bases covered by doing this. Common App for Design Excellence, what's that all about? I don't know about you guys, but when I see design awards programs, even local ones, at times I'm like a little disgruntled that it's just designed for the design awards for aesthetics only, and it has nothing to do with, in sometimes, function, or certainly not sustainability. So this is an attempt to wrap the principles, the 10 framework for design excellence, these 10 principles into a design competition application. So I included that, and that's what AIA California Residential Awards, AIA California Commercial Awards, and some local awards and the national awards are now using. So check it out. The purpose is, what if you were able to fill out one application with some photos, submit it for a local, state, and national awards program? It's way less work. And what if it rewarded projects for doing sustainability and conserving water and being energy efficient? And a lot of the people who only design for looks, they fail when I grade them at the AIA California, and they don't bother to fill out the energy portion of the form or the water savings portion of the form. We get a low grade on the sustainability quotient because they didn't fill the application out completely, probably because they didn't take any of that stuff into consideration when they designed their projects. So it's going to start acknowledging projects that are making a dent in the things that we care about on the environment, on the awards front. So it's a consistent project data entry field that covers all this stuff. So it's common metrics for water, common metrics for energy, common metrics for real super simple embodied carbon. And then it creates this weird spider graph. It's like a circle. If you do bad, you're in the middle. And if you do good, you're farther away from the center. So each little radius is like energy, water. So the bigger your polygon, the better your project is performing. And it's kind of an interesting way if you play around with the little sample Excel spreadsheet that generates a polygon up there, depending on how you fill it out. So here's a couple lessons learned I have from doing this kind of stuff. We design for performance, not just for compliance. What does that mean? Early on, when I was working with my energy modeler, he would stop doing the energy model as soon as he got to like 10 or 20% better than Title 24 and go, that's got enough fluff in it. No need to do to the nth degree. We won't calculate thermal mass of the building or all this stuff because he's legal. And then I said, dude, come on, it's a straw bale house with an insulated slab with hydronic heating, heated by solar with no air conditioning. It's got to be better than that. I'm like, yeah, well, you want us to do the whole calculation? I'm like, yes. So now the guys I work with are trained to design for performance and provide me the energy Title 24 documentation for performance, not just we cross the line and can stop running now. We're looking to get a good time when we're running, where it's not, did you finish, pass, no pass, it's how fast did you run the 100-yard dash. So these guys are working on that now, and they're kind of somewhat trained to do it. Designing zero net carbon buildings, starting to do that, push for all electric. Every building's an opportunity. I used to only think the ones that were an opportunity were net zero energy projects, or ones I could get up there and then we'd like slack off. Oh, that gigantic store, it's not even worth the effort to really try to push them because there's so much resistance. Now we're pushing that harder because it actually makes a big impact in our bottom line. We review our DDX speedometer and we make adjustments accordingly in our project portfolio and how we're addressing projects and energy conservation. Small gains on large projects equal large gains on small projects. So this project, David Knight did a TI with me on this end here, Monterey Energy Group, before the whole project was baked for the outside. This thing was ridiculous. It was like a glass box built in the 60s. It got way too hot on a 70-degree day in Goleta, California, right by Santa Barbara, because it didn't have any operable windows, and it was like a car parked in the parking lot because it took sun all day. And so they decided to put black tinting on all the windows, which only made the glass hotter. So it felt like a toaster. If you put your hand about 6 inches from the glass, you could feel the heat coming off of it inside the building when it's nice and cool outside. So, we had to do a bunch of stuff, but we did design the building to have Lumex solar panels all around the upper floor to shade the glass, swap the glass out for thermally broken, dual glazed storefront, redid the main engine that running the four pipe system, redid the chiller, super efficient, redid the boiler, moved the chiller to the ground mounted one, and still using the 4 pipe with some super efficient little mini systems that are pulling the heat off of the central plant. And then we put solar on the entire roof in addition to just the solar around the perimeter, and divided it up into little cells that could be addressed to each meter section in the building, because I think there's about 9 different electric meters. So each one has its own inverter and its own little bank of electric panels, solar panels that are on the roof generating power for it. So the house uses are taken up by some of the panels, and then each individual tenant kind of meter is taken up by some of the others that can be put in there. People always ask, dude, it looks so expensive. How much extra do you charge to do energy efficient design? And I ask them, how much do you charge to design a beautiful building? Do you just get an ugly one? Unless they want to pay extra to have you put the extra effort in to make it nice. It doesn't take any extra effort on my end to do something that's high performance. I just need to know to ask my engineers for the right data. So don't design the lowest performing building allowed by law. You can strive for something a little bit better. And there's some developers I talk to who do housing tracts, and they're like, what? You want us to do what? Put that on there? It's going to cost us so much more because we're right at the line of being illegal. And I'm like, dude, set a higher bar. Your buildings are horrible. Put something, more insulation in or something. You can get above minimum performance. So there's a bunch of resources here. I gave you the PowerPoint, so I won't really go through them. But you can click on all these things. The Decarb Coalition has a bunch of things about different types of heating systems, water heating systems, ERVs, and that sort of thing. And the AIA came up with this Architect's Guide to Building Performance. That's pretty handy. This document, which I gave you, is nice to look at if you're interested in getting on the commitment. And then here's the most important fact. These are all the firms that signed up for the 2030 commitment. And I'm sorry you can't read them because it's the horrible conversion from PDF to JPEG to PowerPoint, rounded up. But if it's underlined, that means they made the 80 percentile reduction in baseline EUI by firm size. So 2 columns of firms from small firms, 1 to 9 people. It used to be 1 column of firms, and I was on there maybe 5 years ago. But surprisingly, of small firms, 8 of the firms made the 80 percentile performance. Pretty impressive. Firms 10 to 19, 4 firms are underlined. Firms 20 to 49, 1 firm made it. Firms 50 to 99, 2 firms made it. Firms of over 100 people, no firms made it. What does that tell you? Small firms can get it done. Big firms, they can't get it done. So we're more nimble. We can adapt to these changing design parameters. We can be the innovators. And I think we have to. I think always as a small firm, we think, oh, we can't really make an impact. How are we going to get this stuff done? And, I think the opposite's true. A big firm who maybe has 1,000 people, how are they going to get all those people on the same page? And some of them are doing projects in Dubai or, Somalia or something where they don't even have an energy code. So nothing's required. And, they're building air-conditioned stadiums in Dubai for the World Cup. It's like, how's their portfolio going to manage? That's a huge square footage with below baseline performance that they have to include in the DDX. So I think that we can be the leaders and the innovators, and I'm a firm believer in small companies. And one more thing I want to talk about is energy codes and how they work. So every year, the energy code, every 3 years, the energy code changes. And then every year the DDX changes. And so it's trying to catch up with the software that's doing the energy code requirements. And let me just bail on this real quick. I wanted to show you something. So I was talking to my guy this morning because I started doing my energy input into the DDX for some houses that we're doing. And he said, I go, dude, I can't find the numbers for residential project in the energy calcs anymore for 2019. And he's like, because all the ones we did last year were on the previous code cycle. And he's like, oh yeah, they changed the output to not have it in there. And I was like, oh, that's great. But he said that if you have now my blue beam's going on mutiny. if you have a Energy Pro Title 24 calculation, all he has to do is print out a report called an energy use summary. And I'll just upload it from here. And it gives you a report like this. So the old Title 24, you guys know what that thing looks like, a bunch of no colors anyway. But in Energy Pro, if he clicks a box while he's doing the output for the Title 24 energy calc, you would receive this information for a residential project only. Commercial, it's dialed. And you would get the total energy use, the renewables here. So the energy use, total energy use is these two numbers added together, 4,600, no, 4,362, 3,362. If you add those two numbers together. For the electric load, and this was for an ADU that I did, and he just whipped it out. 0 therms because it's all electric. And we do have solar on the roof to offset the energy use. But all the numbers you need will come out on this form. They don't have to be processed by any of those conversion calculators we got. But it shows you how the energy gets used by month throughout the year, and it's color coded by whether it's for appliances or whatnot there. And then it shows the generation from the PV down below the line based on the changing length of the day. So I just told him, I said, how much time does it take you to print out this report? They said, well, now that we already gave you the thing, I have to find the file, open it up, 5 to 10 minutes. And I said, if I told you I needed it with the Title 24, how much time would it take you? And he said, 10 seconds. So I said, give it to me. Every time my firm asks you for residential Title 24 calcs, I want this report also, and I'll even put it on my plans. I don't care. So this is what we have to ask for residential, because the state was trying to help out and make it so that this information wasn't required because they didn't think anyone was looking at it, but we're actually looking at it. If you use some of the other modeling tools like your Guru and your on Sapphira, or you're modeling your building energy use for residences and some of those other programs, you can extract the same data from that. But this would, just to remind you, called the Energy Use Summary in Energy Pro. And it's this one-page output that just shows you what your fuel use is for fossil fuels, what your electricity use is. And then it'll give you this before you put the renewables in, and then you can add the renewables in to offset the energy use if you want to get to net zero. So I am looking at this with my client because this is a 4-panel system, maybe a 5-panel system to just do this to get to almost net zero. They might as well throw another panel or 2 on there and get to net zero energy, or throw more panels in and then get their house to zero net energy in addition to the ADU. Because 4 panels are about, these are using some panels that are 4x5, I think Solaria 400 watts to get to that generation. So that's the only nuance. The AIA California has lobbied the California Building Standards Commission to require that this document be included in the paperwork that gets submitted to the state again, like it used to be on the 2016. They were like, oh, we're trying to reduce paperwork. I'm like, well, don't take the page out we need. Take any other page out, it's fine with me. So they're going to add it back in the next code cycle. Okay, so kind of made it, 108. So we have some time for questions. I'll turn it back over to you, Libby, and stop my share here.
Okay, that's great. Thank you so much, Paul. I'm sure we've got a lot of people with some questions. I also have David Knight here. I know he had a couple good questions, and Polly will moderate.
I can still only see you and Paul, Libby.
Okay.
Can people see more people? Shouldn't we all be visible now?
I think in the upper right, if you click view gallery view, that'll like give you, it looks like a 3x3 little bunch of squares.
But if you'd like to ask a question live, you can raise your hand and then unmute yourself. But let's start with David. David, do you have any questions?
The question I have is, how do we handle energy use like in a residential project? How do we handle energy use outside of the home, outside of the, electric cars, swimming pool filter pumps, well pumps, everything that goes on outside of the house? If the overall goal is to monitor the energy use, what's the plan there?
Yeah, I think that this is really looking at projected energy use intensity for the standard baseline. And if you are projecting additional uses for, say, Tesla, that you would want to maybe do a little additional study on that, because that wouldn't be coming up as the baseline. And you would be trying to offset that with your energy system. So it's really kind of like an operational load. If you're doing a brewery, for example, something like that, those loads for process loads wouldn't be included in the envelope calculation for the DDX per se, but they could be included in the sizing of the renewable system. That's a great question. And this program is not to overload David. Like, everyone shouldn't go to David and go, David, great, fill out my DDX for me. The goal of this is that we can all become literate about projected energy use intensity and include that in the dialogue with our clients up front, so we can get them to buy into the concepts of crushing down the energy use intensity for the building envelope, the building systems, and then offset the residual energy use that we have with the on-site renewables or community choice power. And when they get that whole picture, they can articulate it to their employees or the people that use their services, that their bread is coming from a zero net carbon facility. Or like with the Forest Service, when I'm able to explain to them what we're intending to do with their building, they're down for it. Like, yeah, you're going into a building with no gas, we'll save money on that infrastructure, and we'll spend a little bit more money on a VRF all electric system. And, they have showers and they have condensing water heaters for hot water. It's not going to be as quick as gas, but it'll be adequate for their use. And they're environmentalists and they're ecologists, and they're like, we're down for that. That's what we want to do, because that's what our building should say about us. And in that unique case, the building was owned by a private developer and leased to the GSA for their use. So it wasn't a typical GSA project that had to be LEED certified. It was a private sector project being leased to the GSA that we were able to do the intentions and finance the intentions of the tenant, who ultimately was the Forest Service for Los Padres National Forest. So does this stuff make sense to you, David?
Yeah, no, it does. And I loved what you said about the energy code, because it's a battle I tried fighting 30 years ago regarding the minimum standard meant everybody met the minimum standard, and there was absolutely no incentive to go beyond it. And like every other battle I've had with the state, I lost, but I lose gracefully. So, but I'm glad that the AIA is looking past the minimum standard and going towards something a little better.
Oops, you went on mute somehow, David.
I have a question. I'm sorry I don't have a video, but it for some reason my video seems to be broken, I guess. Does everybody here, I wouldn't mind seeing a show of hands, really understand when they look at table C3 what they're looking at and what the columns mean? I know we all hate to admit that we aren't really reading something, but in my experience, a lot of people just skip over their Title 24 and don't really study it. So I'm curious about that.
Oh, let me show it to you again and I'll try to explain it. David can chime in too, because he probably knows, I know he knows more than me about it. So anyway, this is that one again from the weed farm processing plant we were doing. So this is C3. So let's go up to the beginning. So this is how the whole thing just gets set up. It's a bunch of stuff that the engineer puts in there. If it says TDV, you don't want to use that. That's time determined valuation for energy use. So the utility companies like to look at this because that has to do with impacting the grid with peak hour loads. But it's harder to convert that into PEUI, projected energy use intensity. So all the instructions have a big X through this box, C1. And it used to be table U in the 2016. So if you have projects that are carrying over from 2016, you look at table U, they moved it up to the front in the 2019 commercial, and it's table C3 now. But what this is the summary sheet for the left half of this table right here. I can use my tools. This part is electricity. This part, natural gas. That's how you look at it. So this says the standard design for site electric is all of these things, because it assumes you're going to have a gas heater for your baseline. It assumes you'll have electric air conditioner, you'll have fans, you'll have hot water, a little bit of electric for a circulation pump, some indoor lighting, all these different loads. And then it has the actual calculations of how those things were calculated for your specific design. So it went from 20.7 megawatt hours to 17.3 megawatt hours, saving, the difference in savings is 3.4. This minus that is that. We do it as a percentage. So this is showing, a small percentage of energy reduction. And then this right-hand side is showing gas use or fossil fuel use, whether it's propane, natural gas. So it's showing what it expects you to use for your allowance. Space heating, water heating, total. If it had cooking, it would be in there. But because we went all electric, we got 0 on this side. So I'm saving 100% of my allowance over there, and I'm maybe 70, 80% of my allowance over here. So when these combine together, it'll be better than an 80% because I have 100% on gas side and 80% on the electric side. And then on top of that, with my 80%, I can further reduce that by on-site renewables. So that's kind of how the math works on it. Is that clear, Polly?
Yeah, I think so. How do other people have questions about this? Because when you said 80%, I don't see where that 80% number is.
If I take 17.3 divided by 20 points, 20, oh man, can't even work my calculator.
So that okay.
That 83.5%. If I divide 17.3 by 20.7. But when I combine those two together, it's going to be more than 83% reduction because I get all that energy isn't being used by my design.
Paul,
Cool.
I've got
I'm
another.
I have to apologize. I'm not moderating because I can't see the questions either. I seem to be having a technological failure here. None of the buttons are working on the Zoom.
Oh, I could read the question. It says, for calculation purposes, does it matter if the solar you are offsetting is not going back to the grid, but going to storage, meaning off grid? Only if there's some clipping that happens when your battery is full. So say you generate a ton of power in the summer when the days are longer and you're not able to capture all of that storage, there would have to be some sort of an adjustment for estimating the amount of solar energy that's being generated that's not being stored in the battery because they're at maximum capacity. I have no clue how to do that. But it would just reduce the hours per day that it could generate probably, or something like that. So going to the grid, you're assuming 100% of what you generate, you're able to use. But it gets a little more complicated if you're limited by an undersized storage battery. But if you had a massive battery that you could never, ever fill up to 100%, in theory, you'd get 100% of the solar you generate to be reused.
Paul, I had a question. Are additions part of the DDX? Can you enter them into that?
Yeah, that's cool. Like even a partial commercial renovation. If I'm doing lighting power density, because I'm not touching the mechanical system, I'm not messing with the envelope, there's a 8,000 square foot restaurant, I'm remodeling the dining room that's 2,000 square feet. My operational area would be 2,000 square feet. The light power density calculation from the electrical engineer would be on that 2,000 square feet. And using LED, it's pretty easy to get a 50% reduction in light power density over the baseline. You probably already do it. You don't even know it because you're probably using nice high CRI LEDs that are dimmable in many of those locations, maybe even with daylighting controls, you know? So then when modeled, it'll lower the watts per square foot below the baseline, and it'll calculate you what the baseline would be for an interiors only project. So when you go through at the beginning, instead of new construction, you go commercial interior only, and then boom, it just like eliminates all the mechanical system envelope stuff. And it's just asking you for light power density. And just for the area you're remodeling. So you're doing one little room in a bigger office, you're remodeling 2 rooms, you just limit your scope of work to the 2 rooms you're working on. It's a little making a silo around your project, but you can only do so much what you're working on, you know?
Okay. We got another question in the Q&A.
The question reads, does this approach dilute the passive envelope design that uses site orientation and shading, et cetera, to cut down on the energy use? Passive heating, question mark. What about shade from landscaping? How is that accounted for?
I believe in Energy Pro, there is something about having an overhang over the south-facing glass, but certainly you would get a better performance model out of Sapphira or some of the Revit add-ons that could take into account the super specific design orientation and shading from trees and other objects that would affect a passive solar design. So really to get, and we have done that, not me, but my engineers have done that in the past, use some modeling tools that take a SketchUp model or a Revit model and run a more complex study of how the envelope responds to that. And that's key to reducing the system size. Like we were able to get by with no air conditioning in Santa Ynez by doing a straw bale house with a large thermal mass. And I was a little skeptical that it was actually going to work. And I was a little panicky when I had 40 people there on a tour in the summer when it's 100 degrees out. But the clients know how to open their house at night and get everything cold and then lock it up in the daytime so it maintains that thermal mass cooled temperature. And luckily in San Ynez, they get a wind that comes from Lompoc and the beach up the canyon, up the valley there towards their house that cools the valley at night. So they have good nighttime cooling, but pretty high temperatures. It certainly wouldn't work probably in Mojave, where it's just a desert blowing Santa Ana winds around all day. It doesn't cool off at night. But the math proved true that it could work. So it's kind of interesting to take these micro regional aspects of design into consideration and be able to include them in the design. And maybe certainly Energy Pro, to do a passive house and get it accurately documented, wouldn't work as well to really justify system minimization. It saves money. Spend money on a more complicated model in engineering, and you're able to save money on the installation of a less robust system.
The would you recommend the passive house spreadsheet, what they use?
That system is great. I'm not a master of it. Ed DeVicente, who I saw was on earlier, could probably talk about it because he's passive house certified. I am not. I've gone through the passive house training and I'm blown away by all the stuff that they're doing. And I'm starting to try to use that stuff in the projects that we're using, high-tech vapor barriers and that sort of thing. We've been using ERVs quite a bit because we have humidity issues here along the coast, as you do, I'm sure, to keep the air moving through all the rooms. And then with the all electric mini splits, you have to have that fresh air component as well. But I think all of those things are relevant. The passive house spreadsheet's great. I'm not sure if you can extract data that you can put right into the DDX from that, though. I'm sure you can, or the person you're working with on it could figure it out.
Okay, anyone,
So
any other questions?
Do people feel inspired to try to contribute to sharing the innovation and measuring yourself and seeing how you're doing? And I mean, it's helped me. I thought, I did a straw bale house in San Ynez with all that stuff, and it won, I don't know, 2013 Home of the Year on Green Builder magazine or something. So I was feeling pretty high on myself. And then I'm like, what? The portfolio's only like 19% better than baseline? That sucks. That one project, Superstar, amongst a big giant group of buildings that aren't that good. And like we were only giving the superstars the attention. And now we're trying to make each one a superstar, pushing it as far as it can go. Even if we sometimes getting it to 30% better than baseline for a large project is like a moral victory because it's the first one they've ever done. And maybe we've done it guerrilla style without them even knowing, or within their budget. It's another way of putting it,
Okay, so we just posted this survey poll, and I'm gonna end the poll and post it. Share results. So we asked, so it's good. We got 75% of people are very likely to sign on. And, if anyone has any questions, reach out to me or Paul, and we can answer any questions you might have.
Actually, nationally also, there's the 2030 commitment work group, and they have open office hours. If people are struggling with getting the data into the DDX and from their energy calcs, or if they have questions about some kind of use, there's always that, like I'm doing a weed processing lab. What is that on the DDX? The closest thing we could find was laboratory, right? But they have office hours where you can ask questions. The work groups make themselves available, I think, once or twice a week between now and the end of March, specifically because everyone's panicking, trying to get their stuff submitted for 2021 by March 31st. So it's a good time to have questions. And It's free. You just try to find when that thing is happening and log into the live webinar, and there'll be some volunteer architects answering your questions that you might come up with. And it's kind of fun I would like to see more small firms get involved, because the program responds to participation. And there was only 10, 15 small firms participating 5 years ago. They started swaying the output from the DDX and the usability of the DDX towards what large firms wanted. But I've been advocating for it to make it more valuable to small firms. We would, as a small firm, you'd really want to be able to see the cross section of what everyone's doing. So maybe I've only done one church before and I'm doing another church, and I want to use the baseline of church performance across the country to establish an aggressive baseline for what my project's going to perform at for, say, a church use. If I have a sampling of one within my office, it's pretty useless, because I could always do better than that. But if I have a sampling of 300 churches across the country, I could say, well, gosh, I got to be in the top 10%. So our church needs to be at this projected energy use intensity. And that means we got to have this much solar to get there. Or it means we got to be able to do this. And you can then have a discussion with your client. Like they say, we want you to do a green church for us, Paul. And I'll go, well, you want to be the greenest church? You have to be here. You want to be the top 75%? You have to be here. You want to be right in the middle? You got to be here. You want to be the lowest performing church in the whole country? How about we go right there? You know, and then they can set their own internal goals. And I now am able to have the vocabulary to discuss that with my client, as opposed to saying, yeah, David will tell me what to do. You know, we can have a discussion with David. David can inform our decision making, and the client, we can bring the client into that discussion about designing for the future and designing for the environment at a professional level, I suppose.
David, maybe it'd be interesting. Do we have any more time at all?
We're right at 1:30. We could take one last question and then we have to close.
I was curious from David, you know, my goal is that as Monterey architects, we really get on this scale and that we perform really well, so that as a board member, I can stand up to people and say, if you hire a Monterey architect, you're getting an architect that's dedicated to net zero. But what I wanted to ask David about is, David has told me before in the past that, you know, he often gets people that just want to make it, just want to get under that line. So they're legal, so they're barely legal. And I'm curious, David, what you, as our kind of premier energy guy around here, do you do any kind of attempt, this is a hard question, do you do any kind of attempt to modify that attitude?
Well, I've always worked for you all. And so I kind of been taking, is that a cop-out to say that? But in general, I take the lead kind of from the architect and from the client. I will say what we've started out almost every new custom home the last 5 years on is a call with the client and the architect, and sometimes the builder too, and try to suss out what are the project goals in terms of energy efficiency, in terms of comfort, in terms of indoor air quality, in terms of sustainability, you know. And so, and usually, and let's, I mean, look, it's the guy who's the person, the whoever's building, let's say in a house, it's their house. And they're going to drive the bus to a large degree. Obviously, we can help guide them. One of the easiest stories in terms of guiding them is how cost effective solar has become compared to the grid. And that's usually where we take the discussion. And we try to take it very quickly to, hey, look, you know, by far the most cost effective way to provide electricity for a house anywhere in California is with solar electric, not with PG&E, not with Southern California Edison. And so that all of a sudden brings zero net energy homes into not just the right thing to do, but the most practical thing to do, assuming we have the space, you know, for the solar system that is required. You know, sometimes that's a big challenge. But in terms of all electric, one final point from us, right now, the fastest people converting to all electric in our practice are tract home builders and apartment multifamily. Why? It's not because their carbon footprint is their largest concern. It's because PG&E has become so incredibly expensive to hook up to the gas grid. They're all running to all electric. It saves them a ton of money up front. And
There's
so that
rebates
part's
too.
what's that?
There's
Yeah.
rebates for tracts of homes that are designed all electric. They can get rebates from the energy networks. I think you guys have one. We have 3C Ren in the San Luis, Santa Barbara, and Ventura County area. I think you guys have a different energy network up there in the Bay Area, Monterey Bay. I'm not sure the name of it, but they have all kinds of programs and rebates that are available.
There you
Great.
go.
Well, Paul, this was very informative. We're really happy you could take the time and present this to us. And we look forward to seeing our numbers, or our members sign up for the 2030 commitment and challenge. And we'll be in touch if we have any questions.
Yeah, great. And maybe another time we can go through the super spreadsheet and the Common App for Design Excellence, because I've been a judge on some AIA California Committee on the Environment awards programs. And so I've seen how the disparity in how the forms are filled out. And I'd recommend that if you guys have a committee that's getting an awards program for the local chapter together, you guys scope that application out and see if you should include it maybe with your own local design awards as well.
I can respond a little bit to that. In that our last design awards, we did recommend using the Common App to kind of get people introduced to it. A lot of people had trouble with it, and most people gave up and didn't submit it. So that's a definitely something we need to learn.
Yeah, it's the kind of thing that could be filled out by the project manager and probably be very difficult to be filled out by the secretary, if you will, or the PR person who had no contact with the job, right? Say you have a full-time PR person who just writes flowery stuff about the projects and you give her that or him that, it'll be pretty tough because it asks for numbers. It asks, what's the square footage? How much did it cost? How close is it to transit? How'd you address water conservation? People who aren't in that know about how the project was designed can't just do a fluff piece on it. It has to be having some bones to it. But the ones that do have bones, and if you're looking and reading the Common App when it's completely filled out, it's pretty awesome. You're like, wow, they considered that. That's incredible,
Great. Okay, so we're going to end the webinar now. Thank you so much, everyone, for attending. Have a great weekend.
Thank you, Libby.
Thanks.
Bye-bye.
Paul.
Great.